Okay, so number 45, it's usually a tricky one. Well, when I printed off all the assignments, I didn't do a color copy. And so what I've done is I've redrawn this, and I'll show you. The question is wanting to know that, let's see, yeah. All right, so the question is asking that if we throw a dart randomly at this dartboard, then what's the probability that's going to hit a green region? So here's how we're going to do this. I'm going to talk through it, and then you may see a pattern that you can just apply to your homework problem in case these numbers are different. So the total space of the dartboard is this entire thing, this entire square, all of it, okay? So the first thing I need to do is find the area. I think I'll use a different sheet of paper. Might need to use this again. Okay, so I'm going to first find the area of the big square or the big dartboard, okay? So the sample space is going to be the area of the entire dartboard. Which in this case is the area of this thing. This is a square. Each of these are squares. And so the area of a square is side times side. So the area of this thing is 12 inches times 12 inches, which is 144 inches times inches is inches squared. Now I don't really need the inches squared. You could just think about it with these numbers. Because at the end of the day, that's all that's going to matter. Okay, so now I have to figure out what percent of space does this green take up. Okay, well, this green square is easy to find. It's 9 by 9. So I'm going to say the area of the outer green square is 9 by 9. So 9 inches times 9 inches is 81 inches squared. By the way, this S that we just found up here, this is going to go on the bottom. That's the bottom number, the 144. So in our probability, that's our bottom number. Okay, so I just found the area of this green square. The problem is now we have all this stuff here, that blue square. So I got to get rid of that. Then you probably notice that's going to get rid of that as well. So let's go ahead and say we will have to, we'll do it at the end, but we will have to subtract off the inner blue square. Okay. So the area of that, area of the inner blue square is 6 by 6, so 6 inches times 6 inches, of course that's 36 inches squared. But we also will want to add back this inner green square. So let's find the area of the inner green square. We will add back the area of middle or inner green square, which is 3 by 3 in my case. So that's 3 inches by 3 inches, which is 9 inches squared. Okay, so here is the probability of green. And so you could probably use these numbers to work your problem out if these numbers are different. Okay. So I'm going to write them. I'm going to write it out. So 81 is the outer green square first. Then I have to subtract off that inner blue square. But then we have to add back the inner green square. Okay. And the number on the outside was 144. So let's do the top first. 81 minus 36 plus 9 is 54 over 144. It wants a simplified fraction. So 54 divided by 144. We've got a decimal, so second PRB, we've got 3/8. Okay. So I'm going to show you kind of a summary that you might can apply to yours. So let me move this up here. So I'll say in summary. In summary, probability of green on this guy is, so on mine it was 81. That 81 was because 9 squared. Then I subtracted off this 6, this 36, which is 6 squared. And I added back this guy here, which was 3 squared. And the number on the bottom was this outer one squared. So you might can look at that. That may be more complicated, I'm not sure. But you could look at these numbers and say, oh, well, it's just this, this squared minus that squared plus that squared all over that squared. And you will knock this out in about 10% of the time it took for us to do it here. Okay, so there you go.